Hello, welcome to another video from AnandBapu.com. Today I will be showing you how to take the remainder of numbers when divided by various different numbers. First, I will start by teaching you how to take the remainder when divided by a power of 2. So let's just say it's for 2 to the nth. So say when we have x divided by 2 to the nth. So x can be written as many different, like let's say a1 times 10 to the 0th times plus a2 times, let's just call this a0, and 10 to the 1th. Okay, and then times 10 to the 1th plus dot dot dot, like all the way until an times 10 to the nth. Anyways, 2 to the nth, so let's say 2 to the 1th, 2 will be divides 10 to the first evenly. So if x were equal to 2 to the 1th, then all this would be equal to a0 times 10 to the 0th. That would be the remainder. However, that is not the case. For 2 to the nth, it's divisible for everything below 2 to the nth. So what do? Without overcomplicating this, if you have 2 to the nth, that means if you have 2 squared or 2 cubed, you look at the last n digits and take the remainder of that. If we were dividing by 2, then we would look at the first digit as it's 2 to the 1. So I'll give you a few examples. So 83 divided by 2 has a remainder of 1. 72 divided by 2 has a remainder of 0 because 2 divides 0. You can just memorize this like 2, 4, 6, 8, but it's fairly easy to remember. Now I'll show you how to do anything that ends with number 3. If a number ends in 3, that means that we can add up all the digits and divide that sum by 3. The proof of this is because if we can write the number x equals a sub 0 times 10 to the 0th plus a sub 1 times 10 to the 1st all the way to a sub n times 10 to the nth, 10 is equal to 1. 10 divided by 3 is equal to 1, right? So that means if we were to use modular arithmetic, we would get a0 plus a1 plus all the way until a to the a sub n. In essence, you're adding up all the digits and you're dividing. Okay, so now we will I'll show you a few examples. So 809 divided by 3. So first we will do 8 plus 9 equals 17. I will divide this and get 2. I divide this and get 2. So this has a remainder of 2. However, if this is a little too big, sometimes you can have many digits and it'll be a little big. You can do 1 plus 7 equals 8. Divide that, and then we get 2 again. Okay, I'll show you another example with 617. 6 plus 1 plus 7 equals 14. 14 has a remainder of 2. But if you wanted to, you could do 1 plus 4 and get 5, and then get 2. Now I'll show you how to do with 4. Since 4 is equal to 2 to the 2nd, we will look at the last 2 digits. So if 618, we will look at 18. 18 divided by 4 has a remainder of 2. Another example would be 519. No, I'm sorry. Maybe 879. We will look at 79 and we would say 76, so it has a remainder of 3. 76 divides 4, so it has a remainder of 3. Now, dividing by 5, The proof for this is fairly simple. Just look at the last digit. So like if it's 863, 3 has a remainder of 3. And if it was above 5, you had 869 maybe. 9 divided by 5 has a remainder of 4. Okay, now moving on to 8. It's a little more complicated, but it relies on the same principle. 8 is equal to 2 to the third. So what does this mean? We look at the last 3 digits. So if we had 2,719, 719 is equal to 720 minus 1. So this would be equal to 712. Sorry, 1 second. 712 plus 7. So the remainder is 7. Now I will now show you how to do this. How to calculate the remainder when divided by 9. Sorry. Okay, now if we were to divide by 9, it goes with the same principle as 3. We just add up all the digits and take the remainder. So for example, 603, we would do 6 plus 3. We do not need to add the 0, and we get 9. 9 divided by 9 has a remainder of 0. Another example would be 813. 8 plus 1 plus 3 is equal to 9 plus 3 equals 12. 12 has a remainder of 3. Okay, and now 11. This is by far the most complicated out of all of these. But like the other one showed, it's not too complicated. 11. So, like I showed it earlier, every number can be represented as A0 times 10 to the 0th plus A1 times 10 to the 1st all the way to A sub n times 10 to the nth. Now 10 has a remainder of negative 1 for 11. So what do we get? We get negative A sub 0 plus A1. I'm sorry. We get A sub 0 minus A sub 1 plus ... And then if A sub n, if A sub n is an even number, we would have plus or minus A sub n times 10 to the nth. So I'll show you how to do this. So say we had the number 637. We would do 7 minus 3 plus 6. So we get 7 minus 3 is 4. 4 plus 6 equals 10. 10, so that has a remainder of 10. Now 319, we would do 9 minus, or we could do 9 plus 3, 12, minus 1 is equal to 11. And 11 has a remainder of 0. Thank you very much for watching this video. I hope you enjoyed it. If you have any questions, please don't hesitate to email me at anandvapumath@gmail.com or to leave it in the comments section below. I will be happy to respond. Thank you very much.